The lesson topic for this video is synthetic division. Now you remember that with polynomials we have now added polynomials by combining like terms, and subtracted polynomials pretty much by combining like terms after distributing the subtraction symbol. And then we've also multiplied polynomials, and we've used FOIL for that, and some teachers used matrix, like a matrix table for that and things like that. So what we haven't done yet is divided polynomials. So you'll see right here, this is what a polynomial being divided by another polynomial would look like if we used our kind of old way of looking at division. If you remember things like 10 divided by 4, stuff like that. So we used what we called long division. All right. So we're going to use a process similar to that in synthetic division. Now the 6 steps listed right here won't make a lot of sense right now until we go through an example. So first I'm going to go through an example, and then we can refer back to these steps as we do so. Okay, so our first example, we're going to divide using synthetic division, and we have our dividend, which is this here, and we have our divisor right here. So our original polynomial and then what we're dividing it by. The first thing we're going to do is we're going to write the coefficients of the dividend, filling in 0 for any missing term. So the coefficients are the number in front of the variable term, so 2, 9, positive 14, and positive 5. So we're going to write those down, and that's at 2. Sorry, that was kind of messy. Here we go. All right, so 2, positive 9, 14, and 5. Now, notice it said filling in 0 for any missing term. Well, what that means is if we think about standard form of a polynomial as we have here, we have x to the third, x to the second, x to the first, and then our constant, which is technically x to the 0. So 3, 2, 1, 0, which means we're not missing any terms. If we were missing, for example, like this whole term, we would have to fill in a 0, and I will show an example of that later. Okay, so now we're going to set the divisor equal to 0 and solve. Okay, so this is the divisor. I'm going to take that divisor, x minus 3, I'm going to set it equal to 0 and solve. So that means we're going to add 3 to both sides, and x equals 3. Now we're going to write this number outside of the bracket. All right, now we haven't drawn in the bracket yet. Here's the bracket. It's going to look something like this. Okay, and we're going to write that 3 outside of the bracket right there. Now, step 4 says to multiply and add through the polynomial. Now that doesn't make much sense until we go through this first example. So the first thing we're going to do is we're going to bring this 2 down to right here. Okay, now what we're going to do is we're going to multiply this number out here, the 3, times this number down here, 3 times 2, and we're going to write that answer here, 6. So 3 times 2 is 6, and then we are going to add. We're going to add these 2 values. So 9 and 6 is 15, and then we're going to multiply and add through the polynomial. So we're going to keep going. So we have 3 times 15, which is 45, and then we are going to add, and that's 59. And then we are going to multiply again, 3 times 59, which is 177. And then we are going to add. And 5 plus 177 is 182. All right, so we have done step 4. We have multiplied and added through the polynomial. Now we're going to box off the remainder on the far right. Now the remainder is this value right here. It's the last sum that we come up with when we add vertically. So that is, on the far right, that 182 is our remainder. And now we're going to fill in the variables for the answer. Now what that means is we are going to use these 3 numbers as our new coefficients, and this is our remainder, when we write our answer. And when we do that, we are always going to then include some sort of x term with these coefficients. And the rule there is if our original polynomial had a third power, so x to the third power, degree 3, our new solution is going to reduce that number by 1, so it will start with a 2. So what I mean by that is we're going to write a 2, and then we're going to write x to the second power. Again, this number right here will always be 1 less than this, because what we've done is we've divided out one of those x's. All right, so plus 15, this number right here comes here, and we're just going to reduce this x squared by 1, so we have x to the first, or just x, and then we're going to write plus 59, and there will be no x on that, because notice we have x squared, x to the first, so this would be x to the 0, which is just the number 1, so there's nothing there. And then our remainder is 182. Oops. Okay. There's our first example. So let's go ahead and try another example, and in this case we do have a skipped term, okay? So if you remember what I was talking about on the previous screen, you'll understand here. So we're going to start by writing our coefficients, 5, 9, and negative 12, but notice we have x to the third, x, which is x to the first, and then our constant. So you'll notice in between these two terms we're missing the x squared term. We must fill in a 0 when we write our coefficients. So we've got a 5, then we need a 0, then we need 9, and negative 12. Okay? We didn't have an x squared term, so this is a 0. All right, so now the second step is we're going to take that x minus 2, the divisor, set it equal to 0, and solve it. So we're going to add 2, and we get x equals 2. X equals 2. So we are going to use that number outside of our bracket right here, and we are going to multiply and add through. Remember, the first thing we do is we bring that 5 straight down. Okay? So 2 times 5 is 10. And then we add, 0 plus 10 is 10. And then we do 2 times 10 is 20. And we add 9 plus 20 is 29. And then we multiply 2 times 29, which is 58. And then we add negative 12 plus 58, which is 46, right here. And we are going to put a box around our last number, and then we're going to write our answer. So we have 5x to the second power. Again, if this up here is a third power, we're going to write a second power, plus 10x plus 29, and our remainder is 46. Okay, I'm going to do one more with you. A couple different things happen here. We have a couple of filling in zeros that we need to do, and also we have a negative in here which we haven't had in the first two examples. All right, so we're going to first start by writing our coefficients. Again, be very careful. X to the fourth, x squared. We've missed x to the third. And then we also get x squared here, and then we have no x, which means we missed x, the x to the first power as well. So when we write our coefficients, we're going to write 3. Actually, let me move that over just slightly. We're going to have 3. We have a 0 for the x to the third. We have negative 7. We have a 0 for the x to the first, and then we have a 5. Okay, I'm going to solve this x plus 1 equals 0 right here by subtracting 1, and we get x equals negative 1. So we are going to put this negative 1 out here. All right, and now we bring that 3 down, and we go ahead and multiply and add through the polynomial. So we're going to take negative 1 times 3, which is negative 3. And we're going to add 0 plus negative 3, which is negative 3. And then we're going to multiply negative 1 times negative 3, which is positive 3. And we're going to add negative 7 plus 3, which is negative 4. And then we're going to multiply again the negative 1 times the negative 4, which is positive 4. And we're going to add 0 plus 4 is 4. And then lastly, multiply negative 1 times the 4, which is negative 4, and add, and we get 1. Again, this is our remainder, and we're going to rewrite our answer. So we have a 3 as the leading coefficient right here, and if this is an x to the fourth right here, this will be x to the third. All right, and now we write minus 3x squared minus 4x to the first plus 4, and then our remainder, and I will write that down here, is 1. Okay, so why don't you go ahead and try this last one on your own and check back to see how you did. Okay, so here's what you should have arrived at for your answer. X squared plus 10x plus 21. Notice there's no remainder in this one, and that is going to be really important for what we do in our next section. So hopefully you got that one, and we will have more on this later.